Hello again. So today we're going to be talking about DNA replication. But before we start talking about replication, I want to make sure that we review so that you remember everything that we've already talked about. So this side on the DNA is called the sugar phosphate backbone. Now, if you remember, sugar is white, which is deoxyribose. Remember DNA or deoxyribonucleic acid. The sugar is the first bead, the white bead, and everything goes into the sugar. The phosphate is the red bead right here, and that is going to make up the backbone. Now, if you remember that each of these have to have a complementary base pair. There are only 4 base pairs, A, T, those two go together, and then C and G, those two go together. Now, if you look at these, I have my A with my T and my C with my G. It doesn't matter which side they're on as long as they are together. They're complementary. Now, what holds the 2 strands of DNA together is this clear thing right here, which is called a hydrogen bond. Now, hydrogen bonds can be broken, which is what we're going to talk about today. So the first step of DNA replication is an enzyme called helicase comes in and it breaks the hydrogen bonds. So to do that, I'm going to break my hydrogen bonds. And some of them are a little bit stronger. Now, these hydrogen bonds are now broken. And so now I have 2 chunks or 2 guidelines or 2 templates of DNA. Now, DNA is considered to be semi-conservative, and we'll talk about that here in just a little bit. So now the helicase has done its job where it has broken apart the hydrogen bonds. Now the primase comes in and tells this and says, hey, you need to start here. We need more DNA. And hey, you need to start here. We need more DNA. So when the primase does that, the polymerase comes in and says, oh, okay, thanks for the help. And it adds more DNA. So let me do that. Now, once we have added that DNA, we start to build a whole another strand. So we start with 1 strand and then we end up with 2. Now, if you look at here, we have 2, we're starting to form 2 new strands. Now we have the new part, which is the daughter part, and then the old part or the original part, which is called the mother, which is why it's called semi-conservative. You can also call it the original strand and the new strand. Either way works, but sometimes you'll hear it called either way. So we have our new strand of DNA, and you might ask, why? Why would we need to replicate our DNA? We have so much of it. The reasoning for that is because when cells, which we have like skin cells and things like that, that are constantly being replaced, those cells have to have DNA in them so that they know what to do and they know what their job is. So every time we get a new cell, we have to start with new DNA. Now, we have this. So we've talked about the enzyme helicase, which breaks apart the hydrogen bonds. We've talked about the enzyme primase, which says, hey, you need to start here. And then we've also talked about the enzyme polymerase. It's the one that comes in and adds the new molecules. Now, polymerase does another job as well. Polymerase doesn't want to make mistakes, which mistakes cause mutations. Mutations are not always bad, but they can be. So they can also be really good. So the polymerase comes in and it checks itself to make sure that it does a nice job and that it doesn't have any errors. Once that has all happened, the final step, which is the ligase. Now, this is really hard to show with my beads, so I'm just going to talk about this. But ligase comes in and it glues everything together and makes sure that we have the 2 strands. Now, I could continue and you will end up with 2 new strands, but I think you get the picture. If you are a hybrid student or an in-person student and you are watching this and you would like to use my beads to help practice, you are welcome to. If you are a remote student, I will get resources to you so that you can practice as well. But thanks for watching, guys. Have a good day.